you look at here, if we have the main memory from the microprocessor side, so now this we have a main memory from the microprocessor side. So this is my microprocessor side. If it's a main memory from my microprocessor side, so it is actually what? 2 to the power 14 cross 8, am I right or not? 2 to the power 14 cross 8. So now what I am going to do, so I am now dividing this into unmanned memory. So this is my microprocessor memory. This is my microprocessor memory. What is the size of the address lines here? What is the size of address lines? 14 bits. If we have a 14 bits microprocessor size, what will be the minimum address? The minimum address will be what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Minimum address or maximum address? Minimum. If you look at the minimum address, so we divide it into a chunk of 4, a chunk of 4, a chunk of 4, and a chunk of 2. What will be this thing? 0, 0, 0, 0. What will be the minimum address? 0x what? 0, 0, 0, 0. Am I right or not? Yes or no? Yes. Okay. Now, if you look at here, what will be the maximum address? Yes, Saeed. What will be the maximum address? 14 bits. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Yes. Yes. What is this thingy? F. Then? F. Then? F. Then? No. 3. Yeah. 1, 1 is 3. 1 plus 2. Because it is 2 to the power 0 to the power 1. It is actually 3. So the last address will be 0x 3 F F. Any question? So this is now the main memory map of the microprocessor. Okay, now please, now think, visualize it. So this is actually the main memory, so microprocessor memory. So the microprocessor memory. Okay, now think of now the physical memory. Now we are thinking of the physical memory. Okay, if you look at think of the physical memory, so now I'm going to do with the if you think of the physical memory, please remember, what is this thing? 2 to the power what? 12 cross 8. So now think of the physical memory. So now this is my physical memory. This is my physical memory. So the physical memory is now 2 to the power 12 cross 8. And if you think of the minimum address, so 2 to the power 12, how many bits for the address lines? So basically 12 zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we can partition it what? 0, 0, 0. What will be the minimum address? 0x what? 0, 0, 0. And what will be the last address? 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Help me. 0x. Am I right or not? Clear or not clear? Just think, not think. Okay, now, if you remember, now this is a logical main memory. This is a logical, not a physical memory. So this is the logical main memory of microprocessor, which is actually how many kilobytes? Help me. 16 kilobytes. This 16 kilobyte memory. And this memory is how many kilobytes? Tell me. 4 kilobytes. So can we partition this logical memory into 4 physical memory? Got? So now what I am going to do is I am now going to partition this logical memory into 4 physical memories. So I can call it main memory 0, memory 0, memory 1, memory 2, and memory 3. Am I right or not? Clear? Okay, now, but the physical memory address start from 000 to FFF. So can we write it here? So what will be the last address for memory 0? 0x, 0, F, F. Am I right or not? Clear or not clear? Okay, now, if you look at here, now the main memory 1 address should start from where? I add 1 here. When I add plus 1 here, what will be the next address? 0x, 1, 0, 0. Clear or not clear? Okay, now, if I, okay, now what I did, what is the offset here? FFF. If I add FFF here, what will be the last address? Help me. 1, F, F, F. And then I add 1 to it. 0x 2000. And please remember, there is 0x 000, then 0001 and 1. And then what will be the last address? and then if I add 1 to it, then got it or not got it? Now the $1,000,000 question is, now what I'm going to do? Now, instead of, okay, now if you look at the MSB sites, what I'm going to do, so I'm now changing the MSB with the red color. So this is red color now. This is now 1, 1, this is now what? 2, 2, this is now 3. And why I'm doing it? I will explain it. Now I'm using with the red color. Okay. So this is D0. When it's D0, for this D0 will be 1. Am I right or not? And for this D1 will be 1. Okay, now please remember. Okay, now let's assume a scenario. Let's assume a scenario that microprocessor generate an address. So now what I'm going to do, so I'm going to rub this up. I'm now going to explain what's going on here. Now think of a scenario. Let's assume microprocessor, now let's assume we are in main memory 2. And let's assume there is an address which is actually 0x25F0. Microprocessor generate that address. And something is written here. Let's assume, okay, now please remember, now this is my microprocessor memory, which is the address line, which is 14, and the data lines is now 8 bits. When the data lines is 8 bits, so the data that is inside here should be 8 bits. Am I right or not? If it's 8 bits, so I can write it. Let's assume the data that is stored is 0x. Let's assume that value is 0x9F. Now assume a scenario. Now what we are going to do, so now microprocessor generate an address. So microprocessor generate this address 0x25F0. So microprocessor generate an address 25F0. If microprocessor generate an address 50, so this will be 0, 0, 0, 0. What will be this thing? 1, 1, 1, 1. Then what? 0, 1, 0, 1. Then? No. 1, 0. This is now my A13 and A12. So A13 and A12 will be 1, 0. Now think, A13 and A12 will be 1, 0. When A13 and A12 will be, okay, now in this case, since microprocessor has generated a valid address, so address should be what? When it's 1, the decoder is enabled. When the decoder is enabled, 1, 0, so this is 0, 0, 0, 1, 1, 0. So D2 will be what? 1. This will be what? 0, 0, and 0. It means that this memory will be enabled or disabled? Disabled. Then what? Disabled. And then what? Enabled. And then? Disabled. One of the main memory is. Okay, now please remember. Now the remaining bits. So this is A13 to A12. And this is what? Tell me. From here to here. A11 to what? A0. So A11 to A00. So this is A11 to A00. So the value that we will get is here 0. Okay, it will go to all, but this memory is disabled. We are not reading from here. We are not reading from here. These two memories will be disabled. And which memory will provide now the data? M2 will provide the data. And what is now the data in this example? 9F. So please remember 9F. Now we have 9F here. 9F is now 8 bits. So this is actually 1, 1, 1, 1, and then 1, 0, 0, 1. This will go where? W where? W7. And W7 is connected to what? D7. Please remember. So now we have W7. Okay, now we connect all these data lines. Please remember. Now we connect all these data lines to where? D07 to D00. So it means that now, okay, this memory is disabled, this memory is disabled, this memory is enabled. It means W07 of this memory is now connected to D07. So this will go to D7. This will go where? Tell me. D6, D5, D4, D3, D2, D1, and then D0. Any question? Any question? Clear or not clear? So this will be Okay, now in this case, I will ask one question in your next midterm pertaining to this lecture or tomorrow lecture. We will continue also this in or tomorrow lecture. Any question? Any question? Should we proceed now? Can you see here? Okay, so now can you see here? This is how it works. This is how, okay, now this is the same thing. Address room is connected here, chip select 1. Okay, now here I have given the name of chip select 1, but I have given the name of chip select 0. It doesn't matter. Only the labelings are different. Okay, the labels are different. Clear? And this is how it works. Clear? We have partitioned the memory chips into 4 chips. This will be enabled place. This is now the explanation, and now I explain it here. Any question? Any question? Now, we are now considering case number 3. We are now considering case number 3. So I am going to rub this up. Okay. So now we have case number 3. In case number 2, A was greater than M and D was equal to W. But in case number 3, we switch it. A is equal to what? M, and then D is greater than M. So let's do it with some examples now. Now, should I wrap this up? Okay, so case number 3, when A is equal to M and D is greater than W, so in this case, we require how many? So do we need more rows or more columns? So we have one row, there we have one column, but now in this case we will have one. And how many columns? We will require D divided by W columns. We will require one row and D divided by W columns. Okay, let's do an example here. So what I'm going to do? So this is now case number 3. Okay. So now in this case, now we have changed the problem. So now if you look at here, now on the microprocessor side, how many address lines are there? This is actually okay. So we have another problem. So this is actually okay. Now let's see. So now let's solve it. The memory requirement of the microprocessor. So the memory requirement of microprocessor is memory requirement is 2 A cross D. So the main memory requirement of the microprocessor is 16 kilobyte. So this is 16 kilobyte. 16 kilobyte. And the width of the data bus is 32 bits. So D is 32. So D is now 32. So this is 2 A cross what? 32. So if your partition is 2 4, 2 10, or 2 3 is equal to 2 A cross 32. So we can write it 2 17 is equal to 2 A cross 2 5. What is 32? 2 5. And if you do it, so this is 2 A is equal to 2 actually this is math. I'm not going to explain it. So this is equal to 2 17 is equal to 2 5 is equal to 2 12. So we have A is equal to 12. So now the A is now A11 to what? And what is D here now? D31 to what? And now here, please remember, we require how many rows? One row. Okay, now on the memory side, if you look at the main memory side, so the main memory side is actually 2 to the power 12 cross 8. So actually, what is M? M is 12. So A is equal to M is equal to 12. What is D? D is greater than W. What is D now? 32. What is W? 8. So how many columns do we need? D divided by W. So we need 32 divided by 8, which we need 4. So when we need 4 columns, so we have, please remember, now we have main memory 0, memory 1, memory 2, and memory 3. And all of these memories had 12 address lines. So the 12 address lines are there. So this is actually what? This is 2 for M cross W, yes. M11 to M00, M11 to M00. So these are the address lines. So these are 12 address lines. All of these 12 address lines are connected to what? A. Then we have D. What is D now? 32. So D 30, 31. Now please remember, what is now the data lines on the memory side? 8 bits. How many bits are there? 8 bits. 8 bits. 8 bits and then 8 bits. And if you look at here, 8 bits. So these, okay, now if you look at here, so now the data lines on the microprocessor size is 32 bits, but the data lines on the memory size is 8 bits. So can we see here, where should we connect this? This is now, please remember, this is now W07 till W00. This should be connected to what? D07 to D00. Then, what about the next lines? Help me, from the least significant bits, then the next bits. Then what can I write here? D15 to D08. And here, D what? D23 to D16. And then to D24. So it means that each chip will provide how many bits? 8 bits. And if you combine all of these bits, the total number of bits, how many bits are there? 32 bits. Okay, what about address stop? So please remember, the address stop is connected to all chips. So all the chips are enabled at the same time. So these are the chip select, chip select, chip select, chip select, and chip select. And read write bar is connected to, and the same thing. So read write bar is connected to OE0, OE1, OE2, or OE3, and a note of that is connected to what? WE0, WE1, 2, and in this case, all the chips are enabled at the same time. All the chips. So let's assume in this class, if we have this class, okay, and the size of the data bus in this class, let's assume I require a data bus of 8 bits. So there are two memories, memory 0 and memory 1. 4 students will be provided from this memory and 4 students will be provided by this section. So the total of 8. Clear? Okay, now what I'm going to do, so now I will draw the memory map. So now what I'm going to do, so I'm going to log this off and I will draw down the memory map. I will explain this. So, and here no decoder is required. No decoder is required. And I'll explain it. Why no decoder is required. Okay, now if you look at here, what I'm going to do, so I'm going to log this off. If you look at the microprocessor side, please remember, on the microprocessor side, what is A? 12. So can I write it here? 2 to the power 12 cross what? 2 to the power, so this is actually 2 to the power A cross D. A is 12, 2 to the power 12 cross. If you have 2 to the power 12 cross, you should not just draw the main memory map. Just draw the main memory map. What will be the minimum address? 12 bits. What will be the minimum address? Help me. 0 is what? 0, 0, 0. What will be the last address? 0x F, F, F. And each data bit, what is the width of each data? How many bits? And let's assume we have an arbitrary address. Let's assume this is my address. Let's assume this is in some arbitrary address. 0x 50A. Let's assume this is an address. This is 50A. This is any arbitrary address here. And let's assume that value is 0x 5932AB16. The data size is now 32 bits. The data size is now 32 bits. Okay, so please remember, this is now how many bits? How many bits are there? 8 bits. So when your microprocessor generates this address 0x50A, so this will go, all the memories will be enabled at the same time. And if this is 50A, where 59 will be stored? 59 will be stored here. What about 32? Memory 2. What about AB? Memory 1. What about 16, not 61. It is hexadecimal, 16. And please remember, this is D07 to D00. So can you see here? Now please remember, now we have 59. Please remember, this will be the question in exam. So I will ask one question regarding this. 32, AB and 16. Actually, now please remember, this is actually, if you convert this into binary, so this is actually 0110, this is 0001, this is 1011, this is 1010, this is 0010, this is 0011, 1001, 5001. Now this is complete 32 bits, the computed data. So please remember, this is what, help me, D31, then what? D30 and blah 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 until what? T0, then what? T1 and blah blah blah. And now if you look at here, the address lines, and please remember, this address line will go to MAR, and if you go to MAR, so if you convert this into binary, so this is 0101, 0000 and 1010, so this is what? A11, then what? A10, then what? A0. Any question? Okay, it's all for today. Thank you very much.